Hi, Assalamualaikum. My name is Muhammad Kushairi bin Johari, and today I will present about the experiment stability of floating bodies. Okay, now we will go to the introduction. Okay, the fluid properties and hydrostatic study has been designed to demonstrate and provide students with hand-on experience and fully understand how the properties of fluid and their behavior under hydrostatic condition. Okay, application of Pascal law and Archimedes law is important to determine properties such as density, viscosity, and surface tension of fluid by understanding the basic mechanics and properties of fluid. Okay, now we will go to the objective to determine metacentric height of a pontoon and to investigate its stability. Okay, this experiment, the purpose of this experiment is to understand the concept of stability. Okay, second, to determine how the floating and characteristic of a pontoon change as it is loaded with weight and tilts. Okay, uh, this experiment wants student to observe the characteristic, the floating characteristic, have if they have a different weight and tilt. So they will make the difference of floating characteristic. Okay, now we will go to the apparatus. So this is all the apparatus that we will use. Okay, first this this is the mesh, and second one which is this, the sliding mesh, and number 3 in here, which is linear scales. Number 4, adjustable mesh. Number 5, transverse shaft. Number 6, pontoon body. Okay, number 7, plumb line string. Number 8 is pendulum. Okay, the dimension of pontoon body is length times width, which is 315 times 180. Okay, this is the procedures for this experiment. Okay, first, the transverse adjustable mesh is opened and the weight of the adjustable mesh is measured. Number 2, the adjustable mesh is reassembled to the pontoon. And number 3, the whole set of pontoon bodies is measured. Number 4, the sliding mesh is measured along the mesh such as the center of gravity occur at the top of the pontoon. Determined by using either a knife edge or by suspending from a lead string around the mesh. Number 5, the sink is filled with water. The pontoon is floated to ensure that the adjustable mesh is in its central position. Okay, number 6, zero datum between the plumb line and scale are checked. Number 7, the adjustable mesh is moved to the right of the center in 10 mm increments to the end of the scale. The angular displacement of the plumb line for each position is noted. Number 8, the movement of the adjustable mesh is repeated to the left of the center. Number 9, the adjustable weight and emptying are being weighted and the volumetric tank is refilled. Step 6 and Step 6 to Step 8 of the experiment are repeatedly from the sliding at the different height up the mesh 50 mm and 100 mm for different center of gravity. Number 10, all reading in the result sheet table 2 are recorded. Number 11, the water in the sink is discharged by opening valve V7. Okay, this is the calculation that I do by handwritten. So this calculation I use the set to data. I will show you calculate how I calculate the value in on the next video. Okay, now we will go to the calculation video. So in this calculation video, have a calculation angle of displacement, calculation for 50 millimeter height, calculation for metacentric height. Okay, they have their own formula for each calculation. So I will show you in this video. Hi, Assalamualaikum. Today I will show you about the calculation. Hi, Assalamualaikum. Today I will show you about the calculation video for calculation for angle of displacement. Okay, so this is the formula, and 330 is the constant variable on this formula. So parameter equal to 10 millimeter. So D equal to 50. So the D is already given, and I use the data set 2 for this calculation. So we just substitute the value of D into the formula. Okay, which means theta equal to tan inverse D over 330. So we just substitute the data equal to tan 15 over 330. So the final answer, theta is 2.60 degree. So we use the same formula for calculation for 50 millimeter height and 100 millimeter height. So this is the formula that we use for the calculation. Okay, now we will go to the calculation for metacentric height. Okay, so the formula is AM equal to MAW times B over the MP times sin theta. Okay, so the value of MP already been given, which is 1.988 kilogram. Okay, this is the value of MP, which is 1.988 kilogram, and the value has been given. So the next value is MAW already has been given, which is 0.2192 kilogram. Okay, all this calculation we use the data set 2. Okay, so for parameter 10, B equal to 15 and theta equal to 2.6. Okay, this data has been calculated before we do the calculation for metacentric height. Okay, so we just substitute the value into this formula. So 0.2192 times 15 over 1.988 times sin theta is equal to 2.6. So the metacentric height is 36.46 millimeter. So this is how we use the formula to find the metacentric height. So we use the same formula for 50 millimeter height and 100 millimeter. Okay, in this presentation, I want to apologize that I have something to correct. Okay, that is not a D, but it's B. Okay, I have missed. Okay, that's my mistake in this calculation. That is not D, but it's B, because when I do this video, I'm too sleepy, so I don't have enough rest. So yes, the correction, it is not a D, but it's B. Okay, this is the recorded data. The value in this table have already calculated by handwritten. So I just do the table and fill the table with the value that I have had been calculated. So this is all the recorded data that I get. Okay, before we play the video of graph plotting and creation, okay, I'm sorry that I forgot to record the how to I make the table for the graph plotting and creation. I forgot to turn on the screen recording while I'm do this table. So after we fill in the table, okay, we select the data. So the other thing that I want to apologize is I don't know why, but I cannot see the selection data. Yes, the screen recording does not show the selecting data. So I just explain here. So we take the chart, smooth and marker graph. So we select all the data and we choose the part, the x-axis and y-axis. So okay, so in the bottom of the graph, you can see the label of displacement of 0 millimeter height, 100 millimeter height, and displacement of 500 millimeter height. So I already selected the data, and the plotting has already done. So I select the displacement of 50 millimeter height to plotting the graph. So after we done all the graph section, we will rename the head title of the graph. So this is how I make a graph plotting and creation. Okay, I'm very sorry again. So the head graph of result, the head title is not a graph of result but the stability of the buoyancy, which is the head title of this experiment. Okay, that's all for my graph plotting and creation. Okay, this is the graph of result. Okay, I already changed the head title of the graph, which is stability of the floating bodies. Okay, now we will move to the discussion. Okay, the stability of a submerged body is acquired when buoyant force is equal to the weight of liquid displaced by the water. The stability of a floating body is stable when it's returned to equilibrium when it is displaced, and unstable if it moves to a new equilibrium when placed. Number 4 is based on the question, and the answer is calculation error. Okay, when the value are not calculated correctly, or the values are wrong written on the data table, this could affect the real value of the experimental. Number 5, stability being an important consideration when floating bodies such as ferries design. A body is in stable equilibrium if it is able to return to its position when slightly disturbed. Okay, if fail, it is because of unstable equilibrium. Okay, after this we will move to the conclusion of this experiment. The experiment, okay, for the conclusion, the experiment demonstrated how the stability of a floating body is affected by changing the height of its center of gravity, and how the metacentric height may be established experimentally by moving the center of gravity sideways across the body. So, uh, the value established in this way agrees satisfactorily with that given by the analytic result Bm equal to I over V. Okay, I think that's all from me for this experiment. So thank you and Assalamualaikum.